Good morning, everyone. Good morning. Very good morning to all of you. So, in today's class, the purpose is that already reactions you have done, mechanisms you have done, and maybe some one-liner type of questions which sometimes is not linked much with the mechanism part. And that's the important point now for some of these students, that these one-liner types are not much linked with the mechanism. These type of paragraphs, these type of direct reactions, our focus is now. So that whenever these direct questions are there, you can easily mark them because you have done it recently and you can recall it very, very fast. Right? So without wasting time, starting with the class 12th organic portion. Now see here, this is a reaction where in haloalkanes it is preparation. So this reaction is useful in 2 points. One, it is for the preparation of haloalkanes. Second, it is also used for the chemical reaction of alcohol. Twice this will be there. And these are very easy reactions. Only thing is you have to remember certain reagents. Mechanism part here not required. So among them, what we are doing it? We are preparing haloalkane means alkyl halide. RCl, RBr, RX, RCl, RX, RCl. We are preparing alkyl halides with from the alcohol. OH substituted with the OH substituted with halogen. OH substituted with halogen. Am I audible? Voice clear? Am I audible? Voice clear? Okay. So I think voice is there. Okay, fine, fine. Yes, Gagandeep, just now, just 5 minutes back. Okay. So here we are discussing the direct reaction, which is useful for 2 chapters, alcohol to alkyl halide, how we can use these 7 reagents. Like, what is first given here? We can take alcohol with HCl, with ZnCl2, which is combiningly termed as Lucas reagent. So easy question can be, friend, what is Lucas reagent? When alcohol treated with concentrated HCl in presence of a catalyst, which is anhydrous ZnCl2. Basically, reaction is what? OH substituted with Cl. How it is? This is not the point today, as I said. Directly, which are easily you can identify, that reactions we are going to discuss. OH with Cl, if this is the reagent used. Second possibility, NaBr with H2SO4. What is the nucleophile? Br minus. OH will be substituted with Br. What is generated? RBr, alkyl bromide. Third possibility, it is PX3. X can be what? It can be Cl or Br. Any of them is possible. Finally, what is important? OH substituted with halogen. That is alkyl halide. Which reaction? Nucleophilic substitution reaction. Every reaction, the same thing is done, nucleophilic substitution, but we have to remember the reagents possible may be HCl with ZnCl2, Lucas reagent. Other possibility, NaBr with H2SO4. Other possibility may be PX3, PCl3 or PBr3 with alcohol. They also give SN reaction. Other possibility, PCl5. Byproducts are important for both. With PX3, the product is H3PO3 also. With PCl5, the product is POCl3 plus HCl. So remember the byproduct for PX3 as well as PCl5. Other most important among them is SOCl2. Why it is important? Because it gives pure alkyl halide formation and the byproducts are gases. So which when you go through after the class even, from this paragraph, this is given here, thionyl chloride is preferred. Why? Because in this reaction, alkyl halide is formed along with the gases SO2 and HCl. Gases will escape the reaction mixture and what we are getting finally, pure alkyl halide is left. Then other important point, primary and secondary alcohols with HCl requires a catalyst. But with tertiary alcohol, what is mentioned? Reaction is conducted directly without even catalyst, even at room temperature. So here, primary, secondary alcohol requires what? Catalyst, whereas tertiary even without catalyst. Why? Concept is stability of carbocation, but if you don't even remember it, at least remember Lucas reagent, At least remember what? This is nucleophilic substitution. But reagents keep on changing. Then, other point in this paragraph. Good yield of alkyl iodide can be obtained by what? Ri we can form in a good yield. We can get the good yield of alkyl iodide. By which way? If we treat it with potassium iodide or sodium iodide in presence of which acid? Phosphoric acid, orthophosphoric acid. In this part, we are not going to use H2SO4. Reason is, if you take H2SO4 with NaI, this H2SO4 acts as an oxidizing agent also, and it reacts with iodide ion. And what is the requirement of this reaction? I minus is the requirement. If oxidizing agent is there, then it will oxidize I minus to I2 also. That is why here, remember, what is required? H3PO4 with Ki, not Ki with H2SO4. Okay? Other reagent given here, red phosphorus with halogen, maybe red phosphorus with I2 or Br2. Reaction remains same. OH substituted with corresponding halogen. These are 6th reaction, and 7th reaction is this one. So in this paragraph, if you are able to remember those reagents, directly you can write the product. Then other reaction in this chapter, a name reaction, Finkelstein reaction. We can prepare alkyl iodide by a name reaction which is Finkelstein. What is taken here? Alkyl iodide is prepared by taking alkyl halide. That alkyl halide can be what? It may be Cl or it may be Br, like here. You can take alkyl chloride or alkyl bromide in presence of sodium, which solvent? Triacetone. Simple reaction, X minus leave, I minus substituted. Again, nucleophilic substitution reaction. That is the meaning of which reaction? Finkelstein, which is basically iodine exchange reaction. What it is? Iodine exchange. What is taken? Alkyl halide with NaI acetone. One halogen substituted with other halogen, iodine exchange, or other name is halogen exchange. Now here, other point is, Ri formed, NaX is also generated. This NaX can be what? It can be NaBr or it can be NaCl, which are what? That is given. NaCl, NaBr precipitate out from the solution. Solution means acetone. So here the point is, NaI is soluble in acetone. That's why we have taken initially NaI acetone. But which are insoluble? NaCl or NaBr, they precipitate out from the solution, and as per the Le Chatelier principle, the equilibrium will shift in the forward direction. Similarly, another name reaction, Swartz reaction. In Swartz reaction, what is taken? Again, it is halogen exchange, but difference is it is fluorine exchange. So here what is taken? Alkyl halide, CH3Br, CH3Cl with fluorinating agents. So which are the fluorinating agents? That is important. These four. These are four. Any of them can be taken. And what is the reaction? Again same. Halogen will leave and F minus will substitute it. That is why it is fluorine exchange reaction. But what is the name? Swartz reaction. So Finkelstein is iodine exchange. Swartz is fluorine exchange. Reaction all same. Nucleophilic substitution reaction. Then generally from the PYQs you can get the idea. Every time some question came from the physical properties, that is very precise, not linked with the any other details of the mechanism or something. So very cut to cut question comes. If you have gone through it, you can clearly mark. Otherwise, logically that time it will be difficult. So halogens are what? They are somewhat more polar as compared to hydrocarbons. That is why what is given there? Due to the greater polarity and higher molecular mass as compared to the parent hydrocarbon, and what are the force of attraction they are working? Which one working? Intermolecular force of attraction. Which one? Dipole-dipole interactions. Because halogen and carbon bond is of which nature? Polar nature. So it has which also? Van der Waals forces also, and dipole-dipole interactions also in alkyl halides. Then the boiling point among them. The boiling point is maximum for alkyl iodide. By maximum molar mass, maximum force of attraction in terms of van der Waals and dipoles. And then up to which part it is going? Ri maximum, RBr, RCl and Rf. This is boiling point order. More is the molar mass of the molecule, more van der Waals force of attraction. Hence Ri maximum, Rf least. This is the general order for boiling point. Then this is the case among isomers. If we have isomers, Then among isomers, linear molecules have more surface area. Hence, they have more van der Waals force of attraction. And spherical molecule means branching. They have less surface area, less force of attraction. As branching increases, boiling point decreases. So here you can remember at least this example, which is butyl bromide, or you can say 1-bromobutane, 2-bromobutane, and tertiary butyl bromide. All are having same formula. It is linear, slightly branching, you can say here maximum branching. So among them, which is least boiling point, as branching increases, boiling point decreases. But this is the case of which one? It is a case of isomers. Among isomers, you will take this case. Then in dihalobenzene, important example is of dichlorobenzene. Among them, in boiling point, generally we get the answer by more dipole moment. So you can remember out of these three, ortho, meta and para, boiling point is maximum for ortho. You can relate it with dipole moment concept also. But you have to remember other two, that meta and para, which is slightly given more in case of dichlorobenzene. Para is more than meta. So order is OPM, which is ortho. Why? You can relate with dipole moment. Other two, you have to remember para slightly given more than meta. It is boiling point. Same way, melting point. In melting point, out of three, one you can remember easily. That para isomers are highly symmetrical, which is given on the previous page. Para isomers are having high melting point as compared to orthometa. That you can remember. Then it is due to symmetry of the para isomers. Para isomers are more symmetrical. They pack better into the lattice. And because of that, what happens? Para isomers melting point more as compared to ortho and meta. Other two, again, just like above example, you have to remember that para maximum, then comes which one? Ortho. So POM, it is for melting point, and OPM is for which one? Boiling point. Ortho maximum in boiling point and para maximum in melting point. Then in terms of density, what is given here? Bromo, iodo and polychloro. Suppose CH3Br, or you can say CH3I or CH2Cl2, they are having more density than water. And density of water is value 1. So bromo, iodo and polychloro, they are more denser than water, whereas if it is monochloro, it is less denser than water. So that example can be framed among them. It is monochloro, value is less than 1. Okay, that line will be helpful. Others are bromo, iodo and polychloro. They all are more denser than water. In terms of solubility, this line will be useful if statement type question is there. Here given haloalkanes are very less soluble in water. Reason can be, you can read after that paragraph, here not taken by it is precise points we are discussing, that because of the no H bonding is there with the water molecules. Otherwise, you can say hydration enthalpy is very less. Hence, they are almost insoluble or very less soluble in the water. Then in this chapter, other terms are given, like from the optical isomerism, but we are not discussing any details of optical, only discussing as per NCERT what are the terms given. That terms are relevant for us. One term is enantiomer. What is the meaning of enantiomers? Those stereoisomers which are mirror image of each other and they are non-superimposable. Those stereoisomers which are mirror images but they are non-superimposable. This is the meaning of enantiomers. Okay? In the notes, if you have written diastereomers also there, but here it is not given in the definition. Next is another part, enantiomers, they have identical physical properties. This line, if you remember, statement type given, you can easily mark it. Enantiomers have what? Same physical properties. Which one? Boiling point, melting point, refractive index, like these are physical properties. But how they differ? They differ with each other in the rotation of plane polarized light. For example, if dextro is there and it rotates by plus 50, levo will rotate exactly minus 50. That is the meaning of this line, that they differ only with respect to each other in the rotation of plane polarized light. If one is plus 100, other has to be equally but minus 100. That is the meaning. Plus dextro, other will be exactly opposite levo. Then other point is racemic mixture. So racemic mixture definition given here. What is the meaning of racemic mixture? Equimolar mixture of enantiomers. Equimolar mixture of enantiomers, 50% dextro, 50% levo. When we mix these two enantiomers in equal proportion, the resulting mixture is known as racemic mixture. And what happens due to that? The overall solution becomes optically inactive, because if one is plus 100, other is equally minus 100. So racemic mixture, overall optically inactive it is. Here example given, butane 2-ol plus minus. Plus minus means it is representing, it's a racemic mixture of butane 2-ol. Then other part from this chapter, which again you can be useful for the one-liner question, that why aryl halides are very less reactive towards nucleophilic substitution. Generally, you remember alkyl halides, we talk about SN1, SN2. Generally, you remember, I hope so. So there we say that X minus leave easily, nucleophile will attack, just like example of alcohols we have discussed. In case of aryl halides, for example, chlorobenzene, they do not undergo this reaction, nucleophilic substitution, easily. Reason, that is the important point. 4 reasons are given. How many? 4. One is resonance effect. What happens due to resonance effect? Between CCl, partial double bond character will arise. So here CCl bond acquires which character? Partial double bond character. So question is, why this is not participating easily? Because CCl bond is not cleaved easily. And why it is not cleaving easily? One reason is resonance effect, that leads to partial double bond character between CX bond, maybe CCl or CBr, whatever. Second reason for less reactivity of aryl halides, hybridization of carbon atom. Now check. In aryl halide, hybridization is what? sp2 with halogen. Here it is alkyl halide sp3 with halogen. CX bond in both cases has to be cleaved. sp2 with halogen is a stronger bond. High bond enthalpy will not be cleaved easily. Hence, second reason is hybridization of carbon involved. In aryl halide is sp2 and alkyl halide is sp3. sp2x bond is stronger. So simple reason, hybridization. Then next one is instability of phenyl carbocation. Suppose if CCl bond cleaved also, although it is difficult, if it is cleaved, intermediate will be carbocation. If carbocation is unstable, if it is unstable, this bond will not be cleaved. And if this bond will not be cleaved, it means halobenzene or chlorobenzene will be not participating easily. So here the concept given, instability of the intermediate. And what's the intermediate? Phenyl carbocation if CCl bond is cleaved, and hence which reaction is not possible? SN1 reaction is not possible. Next reason given, fourth. Remember, 4 reasons are given. If it is given in the statement type, you have to remember apart from first reason. These 3 are also important. Fourth reason, why aryl halides are less reactive towards nucleophilic substitution. Reason is electronic repulsions are there between what? Incoming nucleophile, because nucleophile is approaching benzene ring, and benzene ring itself. Both are electron rich. When nucleophile approach and benzene is present, they start repelling each other because of high electron density on both. Hence, the last reason is electronic repulsions between incoming electrophile and electron-rich arenes or benzene ring. So how many reasons are there? 4. Partial double bond character due to resonance. Second, hybridization of carbon involved. Third, instability of the carbocation. What's the name? Phenyl carbocation. And fourth, electronic repulsions between incoming electrophile and the electron-rich benzene or arene ring. So here, now this reaction is not possible easily. So what is done? We have to put some electron withdrawing groups like NO2. Then this reaction is possible. Which one? Nucleophilic substitution on chlorobenzene by putting electron withdrawing groups at which position? Ortho and para position. So in the notes you have written AR-SN mechanism or SNAR mechanism. It is that one, but again I'm saying, if you remember only this point, haloarenes, they are not undergoing this reaction. That is also sufficient for statement type question. Then how they undergo reaction? one thing is withdrawing group at which positions, ortho and para. Then they will be substituted. So this is directly from the NCERT. It is written here that Cl will leave, OH will come. But is taken here, meet temperature high. Then if you put more withdrawing group, even faster reaction. So you can observe temperature is reduced. If there are three groups, ortho, para and ortho, even faster reaction and just warm water required. In all the three reactions, what is done? Cl substituted with OH. Above also Cl substituted with OH. Then, if it is a meta nitrochloro, like this one little, the effect is pronounced when NO2 introduced at orthopara. Only where working orthopara if the meta position of the electron withdrawing group, no effect on the reactivity of haloarenes. Means meta nitrochlorobenzene, we will say it will not undergo which reaction? Nucleophilic substitution, because condition is strong withdrawing group at which position? Ortho and para position. Then other is a question given in NCERT solved example. Chlorine is an electron withdrawing group. Although this question you will do in hydrocarbon chapter also in class 11th when the revision will be done. That time it is there. It is a part of basically from directive influence and again coming in class 12th. Chlorine is electron withdrawing group. Why? Remember halogens are what? Minus I greater than plus M generally. That is the way to answer. So that is given here, chlorine is electron withdrawing group, yet it is ortho-para directing. So in that paragraph, the key point is the reactivity of halobenzene is decided or controlled by their which effect? Decided by which effect? Inductive effect. They are deactivating in nature. Why? Which decides the answer? Minus I effect. But why halogens are ortho-para directing? It is decided by which factor? Their plus M effect, and NCERT uses which term in place of plus M? Resonance. So chlorobenzene may, they are less reactive towards electrophilic substitution reaction. Reason? Strong minus I. That is the term given here, reactivity. Reactivity means what? Electrophilic substitution reaction. But why they are giving orthopara products? That is controlled by their which effect? Plus M effect, which is the resonance effect. So that line is relevant. Then name reaction of this chapter. Previously we have discussed Finkelstein-Schwarz. Other name reaction, Fittig and Wurtz-Fittig. So recall the class 11th reaction, Wurtz reaction. In Wurtz reaction, what was taken? Alkyl halides with sodium metal in which solvent? Dry ether. Reaction finally RR combined, even numbered alkanes formed. Now similarly, Fittig reaction first. In Fittig reaction, we are not taking alkyl halide, we are taking only aryl halides. Same reaction then. Aryl halide, 2 moles taken with sodium metal in dry ether. Benzene ring combines with benzene ring by a single bond, and that is biphenyl formation. Similar to which one? Wurtz. Here we are taking Fittig reaction with aryl halide, then combining both reactions, that is Wurtz-Fittig reaction. So you will say in Wurtz alkyl halide, in Fittig aryl halide, again same, which metal? Sodium metal in which solvent? Dry ether. R of alkyl combines with benzene of aryl by a single bond, alkyl benzene is formed. So Wurtz reaction, alkyl halide, Fittig reaction, aryl halides, and Wurtz-Fittig combining alkyl halide with aryl halide, resulting into alkyl benzene, resulting into biphenyl, and in Wurtz it is resulting into even numbered alkanes formation. Then next part in this chapter from the polyhalogen. Important term is the chloroform also. Chloroform is kept in this point, dark colored bottles. What is the purpose putting it in dark colored bottles? Reason is the chloroform gets slowly oxidized by the air in presence of light and results into extremely poisonous gas. What's the name of this gas? Phosgene is the name, or IUPAC name, you can say carbonyl chloride, right? And that is the reason we are keeping the chloroform in a dark colored bottle, because if it is not kept, then it oxidizes to a harmful gas which is phosgene, and that reaction also, remember, chloroform oxidation takes place resulting into phosgene plus HCl formation. So that were the key points of which chapter? Haloalkanes chapter. Now Next is alcohol phenol ethers. In alcohol phenol ethers, directly we are discussing the part of reduction, that how to prepare alcohol from aldehyde, ketones, carboxylic acid and ester. As per the NCERT, which are the few reagents given. First reagent given is catalytic reduction. Second reagent is given NaBH4, 2. Third reagent LiLH4, 3 reagents. These 3 are given. Aldehyde, C double bond OH, it will be adding of hydrogen and finally results into formation of primary alcohol. So remember, RCHO aldehyde will be reduced to primary alcohol, right? In presence of any of the 3. Catalytic reduction means what? Hydrogen in presence of catalyst, palladium, platinum or nickel. Second reagent, LiLH4 or NaBH4. They also do the same. Aldehyde reduced to which alcohol? Primary. Ketone reduced to which alcohol? Secondary. You just have to think about addition of hydrogen up to alcohol formation. So aldehyde surely will give you RCH2OH. Ketone will surely give you CHOH. That is secondary alcohol, it is primary alcohol. NaBH4 is milder reducing agent as compared to LiLH4. Hence, sodium borohydride NaBH4 is not taken with carboxylic acid and ester. So here in NCERT they have given one reaction. This is given only with LiLH4, that primary alcohol in which yield excellent yield. So any point is given excellent yield by which reagent, then LiLH4 is used. It's a strong reducing agent, carboxylic converted to primary alcohol. ठीक है, same reaction. Only thing is aldehyde primary alcohol, ketones secondary alcohol, carboxylic keep on adding hydrogen up to primary alcohol formation. Other part will be H2O released. Then here one point given that LiLH4 is expensive reagent. So how to prepare alcohols in bulk amount commercially? So that is given here. Commercially, acids are reduced to alcohols. We are converting carboxylic acid to alcohol not directly, rather doing what? Which reaction? Esterification. So maybe reaction might be difficult for you, esterification, but this part remember, commercially acids firstly convert to ester by reaction, esterification, and these esters are reduced to alcohol by using catalytic reduction. So commercially we are not converting carboxylic directly to alcohol, rather carboxylic converted to ester by esterification. If you remember the name, it's very good. Carboxylic acid with alcohol results into esterification reaction. This ester undergoes reduction by using H2 with palladium or catalytic reduction, resulting into alcohol formation. This is a better way because LiLH4 is expensive, so commercially we cannot use it. Then this is which process? Dow's process. Dow's process, another reaction, you can say name reaction of this chapter, although name is not mentioned here, in which chlorobenzene is heated with, fused with NaOH, high temperature, high pressure. So finally, what is the reaction? Chlorobenzene, Cl leave, and finally which will come? OH. Again, which reaction? Nucleophilic substitution reaction. It is also which reaction? Nucleophilic substitution, where Cl initially and finally OH. Okay, but why this is happening now? You might think about it, that just now I have said aryl halides do not undergo nucleophilic substitution easily. It is also nucleophilic substitution, but why it is happening? Because we have taken harsh conditions, high temperature and high pressure, then this reaction, which is nucleophilic substitution, takes place. Then as usual, physical properties of alcohol phenols. Alcohol and phenols में the key point is as carbon atom increases, boiling point increases, first thing. Second, as among the isomers, as branching increases, boiling point will decrease. That is given here. In alcohols, boiling point decrease with increase of branching. Then this is shown here. Apart from the van der Waals forces, in alcohol, which other thing exists? Intermolecular H bonding. So alcohols or phenols, they are both involved in intermolecular hydrogen bonding, right? Then this point, boiling point of alcohol phenols higher than what? Higher than other class of compounds like hydrocarbon, ethers, alkyl halides, aryl halides, or you can say amines also. Amines are also having less boiling point than alcohol. Then this example is important. It is ethanol, methoxymethane, and propane. That it is not here carbon written. You can say here propane is there. Propane example. Among these three, undoubtedly, you can say which is maximum boiling point alcohol. Reason, intermolecular H bonding. Here it is given high boiling point of alcohol due to presence of intermolecular H bonding in them, which is not present in ether or hydrocarbon. Hence, one thing for sure, alcohol maximum. Now, between them, remember, there is no standard term that ether is more or hydrocarbon is more. So, we have to remember specific example of NCRT. Dimethyl ether is more, slightly more as compared to propane. Okay, these two we have to learn. This two we can get by the logic intermolecular H bonding. Then in esterification reaction. In esterification, if you remember it, it's fine. Otherwise, at least remember aspirin formation. Like here, this is alcohol or phenol, both possible. Here, what is leaving? OH. That is the way to remember it, esterification, if you want. Otherwise, at least aspirin formation, remember. And here, H. Remove water directly. What will be left? R-CO with OR. That is ester formation. Okay, that is the basic meaning. Now, then, what is given here? The introduction of which one? Acetyl group, CH3CO group in alcohol or phenol, like we are taking here. OH is there, and what is introduced? OCOCH3. So introduction of which group? COCH3 group in alcohol or phenol. It is the definition of acetylation. Okay, acetylation means we are introducing CH3CO acetate group on the alcohol or phenol. This is named as acetylation. Now using it here. Acetylation of salicylic acid produces aspirin. This line at least remember. That aspirin is prepared by salicylic acid, or other name is orthohydroxybenzoic acid. By which reaction? Again, acetylation. What can be taken here? We can take anhydride, we can take acetyl chloride. Reaction is acetylation, which will leave here. This will leave here. OH from here, and here one COCH3 will substitute here finally, or you can say this is CH3C double bond O, OCOCH3. Just like in case of carboxylic, OH from carboxylic removed and H from alcohol. Here OCOCH3 and H is removed. So CH3COOH is formed. Plus this acetyl group combines with oxygen and resulting into OCOCH3, acetyl salicylic acid or aspirin formation. So aspirin is formed from which compound? Salicylic acid, or other name orthohydroxybenzoic acid. When it undergoes acetylation reaction with acetic anhydride or acetyl chloride, it results into aspirin formation. Okay, that is the aspirin formation from salicylic acid. If you remember esterification, it's very good. Otherwise, related salicylic acid is the reason for generation of aspirin. Then after that, oxidation of alcohol. So multiple reagents we have done, like strong oxidizing agents, KMnO4, permanganate, or Jones reagent. They all can convert primary alcohol, RCH2OH, finally to which one? Carboxylic acid. They will not stop at which stage? Aldehyde. So strong oxidizing agents for getting carboxylic acid from alcohol, primary alcohol to carboxylic acid, secondary alcohol to ketone. Important is CrO3, which medium? Anhydrous medium, is also useful, but it will stop the reaction at which stage? Aldehyde stage. So what is given? RCH2OH and only CrO3 mentioned. It is, if CrO3 mentioned means anhydrous. Then it is converting up to which stage? RCHO. Then what is given? Out of CrO3 and PCC, a better reagent for oxidation of primary alcohol is pyridinium chlorochromate. It will also convert or oxidize primary alcohol to aldehyde, but what is given better reagent? PCC. Remember that. Pyridinium chlorochromate. It will also convert it to aldehyde just like CrO3, but it is given as a better reagent, maybe in terms of yield or side products. What is PCC? Complex of CrO3 with pyridine and HCl. Now, this example is important. Primary alcohol, alkene, both are present. What happens if you take PCC? PCC will not react with double bond. That's why observe here, double bond alkene or alkyne remains same. Which will react? Primary alcohol converted to aldehyde using PCC. Other point is same. If you take secondary alcohol, it will be oxidized to ketone generally. Secondary alcohol to ketone, whether you take PCC or CrO3. Or if you take KMNO4 also, firstly ketones are formed. After that, if tertiary alcohol is there, it will not undergo reaction easily, but under strong conditions, like these conditions. KMNO4, high temperature, then the carbon chain can be cleaved into smaller fractions of carboxylic acid. Otherwise, generally, tertiary alcohols do not undergo any oxidation. So, if harsh conditions given, elevated temperatures, high temperature, then this reaction is possible. Then here, it is from carboxylic chapter introduced here also, because this part is also related to alcohol oxidation. Primary alcohol to acid, primary alcohol to acid. Which reagent given? Jones reagent. So apart from KMNO4, which medium? Neutral also, acidic also, and alkaline. All three. They convert primary alcohol to carboxylic acid. Second possibility, dichromate, acidified. Third possibility, Jones reagent. What is Jones reagent? Chromium trioxide with acidic medium in aqueous acetone, but here it is not given. So you can remember, it is Jones reagent is chromium trioxide in acidic medium. It will also oxidize primary alcohol to finally carboxylic acid. So which reagents? KMNO4, dichromate, and Jones reagent. They convert primary alcohol to acid, secondary alcohols to ketones. Second set of reagent, which one? PCC or CrO3. They convert primary alcohol to aldehyde and secondary alcohol to ketone. Now third reagent. Third reagent, copper heat. Slight difference. Primary alcohol aldehyde, secondary alcohol ketone, and tertiary alcohol also reacts to give Sidzef alkene as the major product. Then this is which reaction? This is the Kolbe's reaction, name reaction of alcohol phenol ethers chapter. Kolbe's reaction. In this reaction, what is taken? Phenol. And in presence of which reagent? Carbon dioxide in alkaline medium first. Then finally, on the benzene, what will be there? OH is present. Weak electrophile is there, which is CO2. Weak electrophile is CO2. On the previous page, it is given. CO2 attacks electrophilic substitution reaction, and finally, which compound generated? Salicylic acid. If you remember, salicylic acid on acetylation gives what? Aspirin formation. So phenol to salicylic acid, it's a name reaction, Kolbe's reaction. And what is the electrophile? CO2 in Kolbe's reaction. Then next name reaction is Riemer-Tiemann reaction. In Riemer-Tiemann reaction, what is taken? Again phenol. Then reagent is chloroform in alkaline medium or with NaOH. Phenol treated with which one? Chloroform with aqueous NaOH. Finally, on the benzene ring, which group is introduced? Aldehyde group is introduced at ortho position majorly, minor at para position. So in NCERT, what is given? During this whole conversion, phenol, which group introduced? Aldehyde, CHO. At which position? Ortho. That is the final thing. In between, what is the intermediate form? Name is substituted benzyl chloride. So phenol to salicylaldehyde, which name reaction? Riemer-Tiemann reaction. In between intermediate is substituted benzyl chloride. Mechanism done in class, written also, but right now, if you do not remember, minimum remember phenol 2-salicylaldehyde formation. It is orthohydroxybenzaldehyde. ठीक है? By which name reaction? Rimertiman. Above one phenol to salicylic acid, Kolbe's reaction. Other name reaction of this chapter, Williamson ether synthesis. In Williamson ether synthesis, what is taken as reactant? Reactant is taken alkyl halide with alkoxide ion. And by this reaction, we can prepare symmetrical ethers also as well as unsymmetrical. So this method is useful for both. For example, dimethyl ether can also be prepared. Methyl ethyl ether can also be prepared by which reaction? Williamson ether synthesis. What is the reagent taken in Williamson ether synthesis? Reagents are alkyl halide with alkoxide ion. It is again which reaction? Nucleophilic substitution. Specifically, if you say SN2, general term, it is also nucleophilic substitution, which will leave X minus leave. When X minus leave, which will attack here? Alkoxide ion, which is nucleophile. And what it generates? R attacked by O minus, and it is bonded to R dash. This is ether formation. That is the meaning of which reaction? Williamson ether synthesis, in which what is taken? Alkyl halide plus alkoxide ion, sodium methoxide, and in solvent will be generally ether is taken. X minus with nucleophile ether form. The point is, the reaction involves which attack? SN2 attack of the alkoxide. Nucleophile is alkoxide, and what is the substrate? We can say one of the substrate is primary alkyl halide. So key point of Williamson ether, it is for both preparation, symmetrical, unsymmetrical. Reactants are alkoxide ion and alkyl halide. Which reaction? Nucleophilic substitution, specifically SN2. Other point, primary alkyl halide should be taken. Which degree? Primary. Then it is favorable for Williamson ether synthesis. Otherwise, ethers will not be formed. How? That when you go through the next page, if you want, then you will get the idea that why it is not forming, because it results into alkene formation. Now, physical properties. In physical properties, what is given? Ethers are polar, but they are weakly polar, and this polarity is not affecting their boiling points. Hence, what is the observation? Their boiling points is comparable to that of alkanes of similar molecular masses. So that's why I said at the beginning, in ether and alkanes, we cannot compare. We can simply say that we have to remember the example because they have comparable values, means maybe ether more in some cases, maybe alkane more. But what we can say for sure, much lower than the boiling point of alcohols. Alcohols have more boiling point. Simple reason, intermolecular hydrogen bonding is there. Then this example important. Alcohol maximum, undoubtedly. But among these two, ethoxyethane and N-pentane. N-pentane slightly more than ethoxyethane. So remember this second example. Although in between salt examples are given that you have to read it. Previously we have discussed dimethyl ether with which one? Propane. Which was more? Ethoxymethane. Now ethoxyethane less and pentane more. Other point, miscibility of ether with water means when you put ethers in water, they resemble the solubility just like alcohols. Reason, they can also form hydrogen bond with water. So among ether molecules, no H bonding, but when you make them soluble or put in water, they are also soluble in water. Reason, they undergo hydrogen bonding with water, hence their solubility resembles that of alcohol. Which example given? Ethoxyethane and butane 1-ol. They are similar, soluble in water, both forms H bonding. Which bonding? Intermolecular H bonding with water. Then cleavage of CO bonds. Here mechanism is involved, that part we are not discussing. Only other points like ethers among the all groups are least reactive. So that is why they require some drastic conditions in the reaction. Drastic conditions with excess of hydrogen halides. Okay? Other point, this is important because previously also 1 year, 2 years back question asked aryl ethers. If you remember SN1 of SN2 of ether, that is good. If you do not remember the mechanism, then only at least remember this part. RO with benzene, what's the name? Alkyl, this is alkyl, aryl ether. Oxygen with both side R group. Whenever this reacts with HX, always which bond should be cleaved? Alkyl oxygen bond. Always alkyl oxygen, which is not cleaved, aryl oxygen. That is what given here. Are cleaved at the alkyl oxygen bond. Due to more stable, which bond? Aryl oxygen. Why this is more stable? Because of resonance. Partial double bond character will arise. The cleavage of aryl oxygen bond will be difficult. That is why remember alkyl oxygen bond always cleave. ठीक है? HX O minus will take H plus. Always the product is always one side product is fixed. Phenol. Other product depending on the alkyl group are attacked by X minus. What is formed? RX. So if it is alkyl aryl ether, always which side bond is cleaved? It is alkyl oxygen. So one product phenol and other will be alkyl halide formation. Then among hydrogen halides in the reaction, which is fastest? HI. Why? Strongest acid. Then HBr, HCl. And conditions are drastic, means high temperature is also required. Now next is which one? Next is aldehyde ketones and carboxylic acids. In this case, apart from the IUPAC, some questions. Here carbon oxygen bond is which nature? Polar. Why? Because of resonance delocalization. That is what resonance given. It is which nature? Polar nature. And then what happens? It is given the carbonyl oxygen is which center? Electrophilic center, which is acting as a Lewis acid. And carbonyl oxygen is a which one? Sorry, the carbonyl carbon is a electron deficient center, which is electrophilic, and carbonyl oxygen is electron rich center, which is acting as a nucleophile. So within the molecule, two centers are present, electrophilic as well as nucleophilic. Then what is given? Carbonyl compounds have dipole moments and are polar than ethers. Means carbonyl compounds have more polarity as compared to ether. Why? It is a pi bond between CO. Pi electron density is also there. Electron more shifted towards oxygen, so they are more polar than ethers. Now, the high polarity of carbonyl group is explained on which basis here? Due to this resonance, dipolar structure is there. B. Then name reaction of this chapter. Which one? Rosenmund reduction. In Rosenmund reduction, again, particular name reaction, reactants are important. Which functional group taken? Acid halide or acyl halides? Acyl chloride. With which reagent or catalyst involved? H2 with palladium on barium sulfate. Is hydrogenated over a catalyst, and catalyst given is palladium on barium sulfate. This reaction is known as Rosenmund reduction. And what is the reaction? RCOCl. How to remember? Substitute Cl with H. That will give you answer. Rosenmund reduction mein what is taken? RCOCl with H2PDBA. So for substitute Cl with H, answer will be there. This is the basic meaning here for Rosenmund reduction. Then next one, another name reaction, Stefan's reaction. In Stefan reaction, what is taken? Nitrile group cyanide. With which reagent? Stannous chloride with HCl. That is written here. Stannous chloride with HCl. Final answer after hydrolysis is aldehyde. In between imine given, if you remember, it's very good. Otherwise, minimum remember nitriles to aldehyde in presence of stannous chloride, HCl, first step. And second step is the acidic hydrolysis. So RCN finally converted to aldehyde. So previous reaction also aldehyde, Rosenmund. Stefan reduction also Rosenmund. But reactants are different. Here nitrile taken. Reagent stannous chloride with HCl, and second step H3O plus. Then other reagent which can also directly convert. These are direct reactions, no mechanism involved. That's why this reaction, if you recall multiple times and any question come, match the following, you easily eliminate it. Nitriles can also be converted to aldehyde by which reagent? Dibal. Dibal is diisobutyl aluminium hydride. It also converts Cn to CHO formation. Just like which reaction? Just like above reaction, Stephen's reaction. Now here, what are the points given? Cyanide, two-step reaction, Dibal, and second step H2O. Hydrolysis done. Other example, cyanide is present and alkene is present. If you observe, Dibal is not affecting the alkenes or alkynes easily. So in NCRT, it is maintained. Double bond remains as it is if Dibal is present, which will react. Cyanide will finally, on hydrolysis, gives aldehyde formation. So Dibal can convert nitrile group to aldehyde, but without affecting alkene or alkyne double bond, and it can also convert esters to finally aldehyde, both. So Dibal is nitrile to aldehyde and ester to aldehyde. Then another name reaction, which is their Itard reaction. This chapter is so many name reactions, so very important it is. So you can read every reaction. Any easy question in exam, you will not leave. Any mechanism based, any product based, like you have to use some detailed concept, that depends on the preparation you have. But if this is the learning portion directly used, that time it will be easy to mark it if you remember a particular name reaction, reactant, and the reagent used. What is taken here? Alkyl benzene, generally toluene. Chromyl chloride is taken, CrO2Cl2, in presence of which solvent? CS2. Final product is benzaldehyde. So first you remember this one. Benzaldehyde can be prepared by Itard reaction. Chromyl chloride with toluene, final product is benzaldehyde. Here one more term is given. Complex is formed in between. Chromium complex is formed in between this one. Remember its formula. If you have done earlier, so maybe you can recall. Otherwise, minimum toluene to benzaldehyde in presence of chromyl chloride with CS2. Now, this complex is formed, which is a strong reason here that this compound does not further undergoes carboxylic acid formation. So, if you have underlined NCRT earlier, before this page in the paragraph given, some intermediates are formed, they are reluctant to the oxidation, and this is one such intermediate, chromium complex. Another is commercial method to prepare benzaldehyde. Which one? Side chain chlorination by hydrolysis, followed by hydrolysis. Again, toluene, Cl2H nu, alkanes chapter reaction, free radical substitution. How many times substitution? 2 times. And then hydrolysis done. The point is here what to remember. Commercial method of preparation of benzaldehyde is which one? Side chain chlorination, followed by hydrolysis. Toluene again converted to aldehyde just like Itard, but this is a commercial method. Another name reaction, Gattermann-Koch synthesis or Gattermann-Koch reaction. What is taken here? Benzene or maybe substituted benzene. Substituted benzene taken in presence of carbon monoxide with HCl, CO with HCl, and in presence of any of the catalyst, either AlCl3 or CuCl or Cu2Cl2. This is which reaction? It is electrophilic substitution reaction. So benzene with COHCl, remember this combination. You will get only one reaction like this. Benzene with COHCl in the NCRT, no other reaction given with COHCl. Other reactions are there, but they are similar to that, but they are not given in NCRT. So benzene with COHCl finally give benzaldehyde formation. Then other point here, that is physical properties. Physical properties of methanol is gas, other thing is. This was a question last year asked, so the chances are very less, but still go through it. The boiling point of aldehyde and ketones are higher than that of hydrocarbons and ethers. So boiling point of which is more carbonyl compounds more than ethers and hydrocarbons of similar molecular mass is reason. The weak molecular association is present in the aldehyde and ketones. Weak means It is not extremely strong. That is why their boiling point is less than alcohol. But it is sufficiently strong that they have more boiling point than hydrocarbons and ethers. But that association is considered to be weak in nature, that is why their boiling point is less as compared to alcohols and carboxylic acid. Here, weak association arising out of, why this weak association is there? Dipole-dipole interactions. Okay? Boiling point is lower than that of alcohols. And you can also mention as compared to carboxylic acid also, less. And why they are having more boiling point, alcohol and carboxylic acid? Simple reason, they have strong intermolecular H bonding factor. Okay? Then, in this case, another example can be framed. It is given what? Alcohol maximum. Okay? Among the propanol and acetone, which is given more, that we have to remember. Ketone given more as compared to acetone. You can see here ketone, and this is which one? Aldehyde. Ketone more than aldehyde. Both have same formula. Then, out of these two, alkane and methoxyethane, which is given more? Methoxyethane. Methyl ether is given more. So this example, if you remember, you can easily mark N-butane less than methoxyethane, which is hydrocarbon and ether. Carbonyl compounds more than them, alcohol maximum. If carboxylic acid given, then carboxylic acid will be best. Initial members, methanol, ethanol, propanol, they are miscible with water in all proportion. Reason, they form H bonding with water. As carbon atom increases, hydrophobic part increases, solubility has to decrease. Then next one, nucleophilic addition. Now point is, aldehyde and ketones, what is the characteristic reaction? That is one line question possible. Characteristic reaction of aldehyde ketones is nucleophilic addition reaction. In the notes you have written complete set that the characteristic reaction is nucleophilic addition, then HCN addition, alcohol addition, sodium bisulfite, oxime formation, all. But here right now, at least remember, aldehyde ketones undergoes generally which reaction? Nucleophilic addition reaction. Now, among the aldehyde and ketones, which is more reactive towards nucleophilic addition? Aldehydes generally more reactive. How many reasons? Only two reasons. You can remember the reason, that is important. If given, you can easily mark without knowing the mechanism, without knowing the detailed reaction. Key points these are. Aldehydes generally more reactive. Reason, steric effect and electronic effect. As steric effect or steric hindrance increases, in ketones we say reactivity decreases, and other is electronic reason, means in ketones plus I effect is more, hence rate of reaction or nucleophilic addition decreases. So two reasons, steric reason and electronic reasons. The other name reaction, which is Clemmensen and Wolff-Kishner. Clemmensen and Wolff-Kishner both convert C double bond O of aldehyde or ketone, not other carbonyl. Only which one? Aldehyde and ketone C double bond O will be reduced to CH2. Either we take Clemmensen or Wolff-Kishner. So remember the reagents used. In Clemmensen, we take zinc amalgam with concentrated HCl. What is formed? C double bond O converted to CH2, byproduct is water. Then other one, C double bond O converted to CH2, but in between what is taken? Reagent hydrazine with KOH in glycol, and heating is done. Firstly with hydrazine, which reaction it is? If you can recall, it is ammonia derivative reaction. Hydrazine to hydrazine to hydrazone formation. If you do not remember, minimum remember hydrazine, KOH, ethylene glycol, C double bond O to CH2, which gas evolved? N2 gas evolved. Then next is some test. Tolerance test, Fehling solution test. Tolerance test, which reagent? Ammonical silver nitrate solution. This is tolerance reagent. Observation and tolerance test, silver mirror or silver deposition. AG is there. Okay, general points. Then this test is used. Which medium? Alkaline medium. This test is given by aldehydes, not given by ketones. General point, remember, carboxylic acid will not give this test. Generally, formic acid can give. So minimum, remember, aldehyde give tolerance test. Ketones do not give tolerance test. Other points in the notes you have written, if you have a time, you can go through it. Minimum point, remember, aldehydes will give this test, maybe aliphatic aldehyde or aromatic. Ketones will not give. Which ketones can give? This point is not relevant now at this point of time. Fehling solution test. In Fehling solution, two solutions are there, A solution and B solution. In solution A, what is present? Copper sulfate, pentahydrate or aqueous copper sulfate. Solution B, sodium potassium tartrate, which is Rochelle salt. When we mix them, that solution contains copper in which form? +2 ion. Then this test is given by aliphatic aldehydes, not by aromatic aldehyde. Fun thing. Ketones will not give this test. At least remember this point. Aliphatic aldehyde give this test. Fehling solution test. Aromatic aldehydes will not give. Ketone will also not give. Tolerance test given by both aliphatic as well as aromatic aldehyde. Ketone will not give tolerance test. Observation. Red-brown precipitate of Cu2O is formed in Fehling solution. Aldehyde converted to carboxylic acid salt. Aldehyde converted to carboxylic acid salt. In both the cases, alkaline medium is there. Here, this is which test? Iodoform test. Haloform reaction. In iodoform reaction, what is used? It is used for detecting methyl ketones. Iodoform is used to detect methyl ketones, CH3CO, or secondary methyl alcohol group. And which example? At least remember this NCERT example. Here, this is methyl ketone or not? Methyl ketone, not carboxylic acid we are taking. Methyl keto group in presence of NaOH with X2, maybe Cl2 with NaOH, Br2 or I2 with NaOH, that combines to give sodium hypohalite. How to write the product or how to identify methyl ketone? This bond cleave. This is converted to carboxylic acid salt, so one carbon less. And this single carbon with CH3 finally converted to CHX3. If you put here I, it is iodoform test, which is a yellow precipitate, and this is used for detection of which group? Methyl keto groups or secondary methyl alcohol. Remember one thing, iodoform test is given by only one aldehyde, we can say, which is acetaldehyde, which is also just like methyl keto. Which aldehyde gives? Acetaldehyde will give this test, this bond cleaved, iodoform is formed. Okay, apart from that, methyl ketones will give and secondary methyl alcohol will also give this test. Here, important example. Methyl ketone is there, NaOCl means sodium hypochlorite, which bond cleave? This bond. CH3 converted to CHCl3, and this part will give carboxylic acid salt. This remains unaffected in both. So double bond will not be affected with iodoform reaction or haloform reaction. Then important reaction, last year this reaction was there, so maybe chances are less, but still when you prepare the name reaction, aldol condensation, at least these two. In aldol condensation, what is the requirement? Requirement is those aldehyde or ketones, how many moles taken? 2. They should contain at least one alpha hydrogen, at least one out of any of them. At least one alpha hydrogen is present, it should be there, and which medium? Dilute alkaline medium is taken, which is acting as a catalyst. And what is the product formed here? Firstly, form beta hydroxy aldehyde or ketones, means beta hydroxy carbonyl, like CH3CHO. This is alpha carbon. This alpha carbon has hydrogen. In dilute medium, it will give which reaction? Aldol condensation. Then with this condition, firstly, what is formed? Beta hydroxy carbonyl. So if you are able to identify alpha hydrogen, then you can directly write the product also. First product is beta hydroxy carbonyl. On heating, dehydration takes place, and that is the product formed, which is condensation product. Now here, how to write the product. If you at least remember how to write the product, then it will be better for aldol reaction. Like what is given, CH3CHO. Okay, here in this case one molecule written in this manner, not writing the detailed mechanism, that is not useful. If you have worked earlier then it was good. If you possible for you, at least identify alpha hydrogens are there, put 2 alpha hydrogens. Other molecule CH2, H as it is, and CHO, acetaldehyde, acetaldehyde. ठीक है, getting it? If you eliminate water like this, at least you get the final product, that is condensation product. What is generated? CH3. Complete the valency, C double bond, CH, CHO. Now you can match in the NCERT, that is the product given, alpha, beta, unsaturated carbonyl. This is final product after heating. Suppose you have to write without heating. So what is the product initially? Beta hydroxy. So this is beta carbon. Yes. Add water. On beta carbon OH, alpha carbon H, you will get the first product. So depending on the question, you will get the answer. Easy question, you can go for it. Any complicated is there, like cross aldol. So it depends how much practice you have done. But by this way, you will get the final answer easily. So that is the product form. Getting it? First product is beta hydroxy, but if you write the direct reaction, that easy way, remove water, you get the final product, which is named as alpha beta unsaturated carbonyl. So by option elimination also sometimes you get the answer. By option elimination also you get the answer, like this is visible, board is visible. Okay, fine. So here other example, propanol, again alkaline medium. What is taken? Barium hydroxide. Okay, it will be shared. It will be given in the group after the class. Already it was given in the regular classes also, that chapters. But it is precisely, if you want, it can be shared, no problem. Here what is taken? Acetone, again alkaline medium. Barium hydroxide. First product is what? First product is alpha beta. Beta hydroxycarbon. So in the option, firstly what you can check, always check what is beta hydroxy. If it is only given with alkaline, heating is not done. If heating is done, you will check it should be alpha beta unsaturated. So out of the 4 options, generally 2 options gone. If you take propanol, acetone, the final answer is this compound which is named as macetyl oxide. Okay? So this is the point, aldol condensation, key point. Those aldehydes or ketones are taken in which at least one of the aldehyde or ketone contains alpha hydrogen. Which medium taken? Alkaline medium taken, although aldol is possible in acidic medium also. But in NCERT it is not given. What is given? Only base catalyzed reaction given. Okay? The first product is beta hydroxycarbonyl, which is before heating. After heating, it is aldol condensation, which is alpha beta unsaturated carbonyl compound. Then next is which one? Very important reaction we can say, because aldol came last year. Kenny-Zero we can say possibly is there. Kenny-Zero reaction में Which aldehydes will be there? Remember, aldehyde is the term written. Aldehydes which do not have alpha hydrogen, they undergoes Cannizzaro reaction in basic medium. What happens? Self-oxidation and self-reduction, which is named as, it is a type of disproportionation reaction. Then, what is taken? Concentrated alkali taken, maybe NaOH or KOH. In this reaction, out of the 2 moles, 1 mole will be reduced or oxidized to carboxylic acid and other will be reduced to alcohol. Like, observe here. In this case, this aldehyde, both are same nature. They do not have any alpha hydrogen. So you will never think about aldol. You will always think about alkaline medium given concentrated, not written even. We can still think about which reaction? Yes, it is Cannizzaro. Out of the 2, 1 will be reduced to alcohol. So aldehyde reduced to primary alcohol and aldehyde oxidized to carboxylic acid, but salt formation. Why salt? Alkaline medium. Similarly, other example, benzaldehyde. Benzaldehyde is also aldehyde. It has no alpha hydrogen. Alpha hydrogen is not there. It means in alkaline medium, which reaction? Cannizzaro. Hence, 1 molecule will be reduced to primary alcohol, other will be oxidized to salt of carboxylic acid, which is sodium benzoate. So at least solve Cannizzaro reaction also, because it is easy to identify aldehydes that do not have alpha hydrogen. They undergo disproportionation reaction. Okay, then next part is carboxylic acid in the same chapter. Important point, C double bond O was there in aldehyde ketone also. C double bond O in carboxylic acid. Important is carboxylic carbon is less electrophilic than which carbon? Carbonyl carbon. Reason, lone pair will delocalize, positive charge on the C double bond O of carboxylic is reduced, hence nucleophilic attack will be reduced. So point is, aldehyde ketones are more reactive than carboxylic acid towards nucleophilic reactions. This reaction again oxidation, but it is different. Slight difference. Why? Previously we have discussed alcohol. Now alkyl group, alkyl benzene, like this one. Alkyl benzene can be converted to carboxylic acid, aromatic carboxylic acid, by which reagents? Vigorous oxidation with first reagent chromic acid, H2CrO4. Second reagent KMnO4, alkaline or acidic medium. Third reagent possible permanganate dichromate solution also. What is the reaction taking place? Primary and secondary alkyl, they are oxidized to carboxylic group, but tertiary group is not affected. Like here, this is methyl. If you take further CH2, CH3 like this, it is primary. It will be also finally converted to salt if it is alkaline medium. If it is directly acidic medium, final answer is all the side chain converted to COOH. But if it is taken with which alkyl group? Tertiary alkyl. This has no alpha hydrogen or no benzylic hydrogen. It remains unaffected. That's the point given. If it is having benzylic hydrogen, here also hydrogen, here also hydrogens are there, wherever it is possible, then it will undergo which reaction? This reaction. Here how many hydrogen? 1. Here how many? 3. They all will be converted to carboxylic acid. So this is which part? Oxidation of the side chain. Entire side chain is oxidized to which group? Carboxyl group. Irrespective of the whatever carbon chain in length is there. Condition is at least 1 benzylic hydrogen in alkyl part. This is specifically written for which one? It is specifically written for alkyl benzene. Okay, for alkyl benzene, at least 1 benzylic hydrogen has to be there. If you take here aldehyde, it will be also converted to acid, but that is a different set of reaction. It is not alkyl benzene then. If it is acetophenone, it will be also converted to carboxylic acid, but acetophenone is not alkyl benzene. So with alkyl benzene, you will check by which point at least one benzylic hydrogen, then entire side chain will be finally oxidized to carboxylic acid group. Next one, physical properties. In physical properties, carboxylic acids are higher boiling liquids as compared to whatever functional groups in NCERT given. Like acid is there, aldehyde ketones, amines, alcohol, phenol, ethers, haloalkanes, class 11th hydrocarbon. Among these NCERT functional groups which has maximum boiling point, carboxylic acid. ठीक है? Aldehyde, ketone, even alcohols of comparable molecular mass. Reason: strong intermolecular hydrogen bonding. It is the strength of H bonding is high. That is why they have more boiling point as compared to alcohol, aldehyde, ketones like this. But out of the NCERT, if we go slightly, amides have more boiling point than which one? Carboxylic acid. They are having more polarity in the structure, but less important information because amides are not given separate chapter. Then the strength of H bond is so much that hydrogen bonds even exist in the which phase? Vapor phase. Okay, and in vapor phase it exists as dimer. That's the structure given. It is one molecule, it is other molecule. Which bonding? Intermolecular. In vapor state or which solvent given? Aprotic solvent. What is there? Dimer is existing of carboxylic group in which phase? Vapor phase or in aprotic solvent. Then up to first four members, they are all miscible with water. Why? They form easily H bonding. As carbon increases, solubility decreases. Other point, benzoic acid is nearly insoluble in cold water. That point can be useful for statement type. Benzoic acid is nearly insoluble in cold water. Then in acidic nature, one point is relevant more, that is carboxylic acid reacts with sodium metal. Why? It has acidic hydrogen. It reacts with base. Why? It has acidic hydrogen. Important is sodium bicarbonate test. Evolve hydrogen, this one. They react with carbonate and hydrogen carbonates to evolve which gas? CO2. That is the important point. That carboxylic acid will react with sodium bicarbonate. It will evolve CO2. Alcohol will not react. Phenol will also not react. Which phenol can react? Picric acid type. They can also give the test. So right now only at least remember, carboxylic acid gives sodium bicarbonate test, NaHCO3 test, which will not give aldehyde, not give ketone, will not give normal phenols, will not give alcohol, will not give. That easy question if framed among the following, which will evolve CO2. At least remember in NCERT, carboxylic acid is one such group. Salt formed plus CO2 evolved. Then this reaction again here, but slight difference. Why? Previously we discussed these reagents where at the beginning of this session that alcohol can be converted to alkyl halide, OH substituted with halogen. Same concept here, but the functional group is changed. What is there? Carboxylic acid. But concept remains same. Nucleophilic acyl substitution, or you can say nucleophilic substitution. Take OH with Cl, OH with Cl, OH with Cl. Again, which is best reagent? Because the byproducts are gases, quickly escapes the reaction mixture. The main product is present in the pure amount. Then another reaction after these three, ammonia. So with ammonia, carboxylic acid react. It is acid, it is base. Take acid base reaction will be there, salt formation. After heating, water has to be eliminated. And what it generates? Amide. So remember this one, carboxylic acid can be converted to amide by which combination? Ammonia plus heat. Carboxylic acid converted to acid halides by three reagents. PCl3, PBr3, PCl5, SOCl2, and this one carboxylic acid amide with ammonia and heat. Then name reaction in carboxylic acid, HVZ reaction. This HVZ reaction is alpha hydrogen has to be there, or you can say it is which halogenation? Alpha halogenation reaction. What happens here? Carboxylic acid which contains alpha hydrogen with halogen X2. X2 can be Cl2 or Br2. It is given here. X2 is Cl2 or Br. When you take this one and second step H2O, final answer is alpha halogenation. So in alpha position, you will write Cl or X depending upon whatever the halogen given. This reaction is taking place in the carboxylic acid which have alpha hydrogen. Final answer is alpha halocarboxylic acid in presence of red phosphorus with halogen. It's a name reaction, HVZ, Hell-Bollard-Zelinsky reaction. Now last part is amines. In amines, in the initial portion, if you go through hybridization given, in trimethylamine, the hybridization again same, sp3, but bond angle is distorted. It is not 109.5, it is 108 degree given. If you remember this data exactly, then you can mark it. Logically at the time, you cannot decide because due to lone pair, bond pair repulsions, distortion is there. How much distortion we cannot say until we know the value. So trimethylamine bond angle is distorted, which is 108. Then we can prepare amines by which reaction? Nitro compounds reduction. NO2 converted to NH2. Which are the possible reagents? Catalytic reduction. H2 palladium with solvent taken ethanol. Other reagent, second, tin with HCl. Third, Fe with HCl. These three all will convert NO2 to NH2. Important is out of these two, iron scrap and HCl is preferred. Better reagent is this one. Reason not required right now. Remember Fe, HCl and SnHCl, they are metal with acid. Out of these two, metal acid which is better? Iron with HCl. Next is ammonolysis meaning. What is the meaning of ammonolysis reaction? Ammonolysis simple meaning is cleavage of CX bond of alkyl halide in presence of which nucleophile? Ammonia. And what is the solvent taken? Ethanolic solution of ammonia. So any question given among the following or match the following question which is representing ammonolysis, so you will remember one point, alkyl halide taken with ammonia as nucleophile. That is the meaning of ammonolysis. X minus leave, ammonia attacks as nucleophile. Nucleophilic substitution reaction it is. Then name reaction of this chapter, Gabriel phthalimide synthesis. Now maybe by looking at the reaction it is difficult for you to go through it if you have not worked earlier. So key point of this reaction. This reaction is used for the preparation of which degree amines primary. So if any question is given, Gabriel phthalimide is used for which degree amines, you will mark as primary aliphatic amines. Primary aliphatic. Okay? Which cannot be prepared. Primary aromatic amines cannot be prepared. That reaction is given in between SN2 reaction is involved. What is the starting material? Phthalimide. Phthalimide treated with KOH, acid-base reaction. Nucleophile generation. This nucleophile attacks on the alkyl halide, which degree? Primary, by SN2 reaction taking place. It reacts SN2 reaction and alkyl phthalimide formation. Then after hydrolysis are NH2 formed. So remember minimum, Gabriel phthalimide is used to prepare primary aliphatic amines. Aniline cannot be prepared. Secondary tertiary amines not taken. Only primary aliphatic amines. Aromatic amines cannot be prepared by this reaction. Why? Because aryl halide has to be taken and aryl halides do not undergo nucleophilic substitution easily. They are very difficult to undergo nucleophilic substitution. Clear this part. The next name reaction is Hofmann bromamide degradation. What is taken here? Amide. How to prepare amide from carboxylic acid with ammonia heat? That is also possible. So multi-step can be framed. When amide is formed, we can convert it into amine by Hofmann bromamide, but degradation means one carbon is less. RCONH2 with which reagent? Halogen. Br2 with NaOH or KOH. In presence of this mixture, remember the moles also. So here, what is the product formation? Product is remove this CO and combine both of them. You will get the answer. So answer is, it is used for preparation of which amines? Primary. But here the important point is, primary aliphatic also can be prepared and primary aromatic amines can also be prepared by Hofmann bromamide degradation, but Gabriel phthalimide only for which one? Aliphatic primary or primary aliphatic amines. Okay? Then in this case, it's up to you if you are able to remember that point. Minimum point I said, Hofmann bromamide, amide to primary amine, primary aliphatic also, primary aromatic also. Other point, this CO finally comes out in which form? Carbonate. Take other point. Then you are getting amine with one carbon less, RNH2, and that one carbon of CO goes in the carbonate formation. Okay, the amine so formed contains one carbon less than that present in the amide. Then physical properties. It was already marked last year also. These are the points. In JEE Mains this year same question came. Aryl amines are usually colorless, but get colored on storage due to atmospheric oxidation. The question was framed in statement type and written they are colored due to atmospheric reduction. So if you read it properly, it is atmospheric oxidation, just like phenols are there. Phenols also oxidize to dark colored mixtures, quinone. Same way aniline can also be undergo oxidation to dark colored solutions, and this is due to atmospheric oxidation. So that was the question framed in JEE Mains exam this year. Next part, lower aliphatic amines soluble in water, reason H bonding they form with water. As hydrophobic part increases, solubility decreases. Okay? Example can be important, butane 1-ol and butane 1-amine, which will be more soluble. Butane 1-ol is more soluble. Why? Alcohols more polar than amines and form stronger intermolecular H bonding. So such points are very one-liners. If you revise them multiple times, any question came, it's a bonus for you. Because if you are not able to write the detailed reaction, so your focus will be whatever easy question thrown, that I will not leave. That is the purpose of this class. That is the only purpose. So what is the point here? Butane 1-ol and butane 1-amine, which is more soluble? Simple reason, alcohol, they are more polar and their strength of H bonding is more than amines. Other point. Primary, secondary amines, they are involved in intermolecular H bonding because NH2 is there, NHR is there, but tertiary amines do not undergo any H bonding. They have no intermolecular association due to absence of H bonding. Hence, the boiling point among the isomers, primary maximum, more H bonding, secondary less H bonding, tertiary least, no hydrogen bonding. Then next part is from basic nature. In basic nature, aliphatic amines minimum, remember what? Order of basic nature. Basic nature more, if more electron releasing effect generally. So in which phase it is there? It is in gaseous phase. In gaseous phase, aliphatic amines tertiary best 321, and reason is what? It is basically due to which effect? Plus I effect. That is the order. 3, 2, 1, and you can say 0 means ammonia. But which medium? Gaseous phase. If it is which medium? Aqueous medium. 3 effects working: inductive, solvation, and steric. So in aqueous medium, aliphatic amines, important case arises in which is best? Secondary is best. Then if it is ethyl, order will be tertiary, primary and ammonia. If it is methyl, order will be primary, tertiary and ammonia. Secondary best, then 2, 3, 1, 0 order, which if it is ethyl group, 2, 1, 3, 0 if it is methyl group. Reason, three concepts are working together. We can only cross check by the value of pKb. Lesser the pKb, more is the basic nature. Then next is carbalamine reaction. Carbalamine reaction में what is taken? Primary amine. This test is given by which amines primary? Maybe aliphatic, maybe aromatic. One thing. Second, the reagent is chloroform with KOH, similar to Riemann-Tiemann reaction. In Riemann-Tiemann reaction, we have taken chloroform with NaOH, here chloroform with KOH. Primary amine give this test. Observation, foul smelling substance. Take, and what is that substance? Isocyanide or carbalamine formation, which is this one. Getting it? So this is carbalamine test or carbalamine reaction in which primary amine gives isocyanide, which is a foul smelling substance. So other name is carbalamine formation, and which will not give this test secondary and tertiary amines. So this can be a distinguished test between primary amines can be distinguished from the secondary and tertiary. Other reagent which is useful is benzene sulfonyl chloride. So at least remember which part? Benzene sulfonyl chloride is known as which reagent? Hinsberg reagent. Okay? Hinsberg reagent, it reacts, which will react? Hinsberg reagent reacts with primary and secondary amines, but it will not react with tertiary amine. How it is reacting? That is reaction based concept. So minimum remember, Hinsberg reagent reacts with primary and secondary amines, but not react with tertiary amines. Reason is tertiary amine has no hydrogen with nitrogen. Other important line, it is used for distinction or distinguish of primary, secondary and tertiary amines. So Hinsberg reagent is used for distinguish test as well as for separation of mixture of amines. So which test? Hinsberg reagent, one thing. Second thing, its formula, remember this. Reaction, it's up to you. If you are prepared well, so you definitely remember the reaction. If you have not prepared well for this particular concept, you can remember minimum formula used as a distinguished test. And nowadays, which is used in place of Hinsberg reagent, or what is the new Hinsberg reagent, we can say it is para-toluene sulfonyl chloride. Then in this chapter, aniline reactions are given. Only one I am marking here. Aniline does not undergo which name reaction? Friedel-Crafts reaction. Reason, salt formation. Even if you don't remember the reason, minimum remember, aniline will not participate in Friedel-Crafts reaction. Then name reactions which are of diazonium salt. Sandmeyer reaction. In Sandmeyer reaction, what is taken here? Diazonium salt. Arene diazonium salt, which is stable at which temperature? Low temperature, 0 to 5 degree. In Sandmeyer reaction, how many reactions are there inbuilt? 3. Chlorobenzene, bromobenzene and benzonitrile or cyanobenzene. Reagents, copper is taken in +1 state, CuCl, CuBr, CuCN. Take with HCl, with HBr, with KCN. Final answer, N2 evolve and Cl or Br or Cn will substitute. Sandmeyer reaction is a Sandmeyer reaction involves free radical formation, but this information is nowhere given in NCERT. So the intermediate point is not important. Intermediate nahi important. Important is direct conversion. Diazonium chloride to chlorobenzene, bromobenzene, and benzonitrile. Next one is Gattermann reaction. In Gattermann reaction, again diazonium salt, but slight change in the reagent. What is taken? Copper powder with HCl, copper powder with HBr. Products remain same. Chlorobenzene, bromobenzene, N2 gas evolve, and this X minus combines with Cu plus. Out of Sandmeyer and Gattermann, which is better reagent? Sandmeyer is a better reaction because here mentioned yields are good in Sandmeyer. Replacement by iodide ion. We can convert diazonium chloride to iodobenzene also. What is the reagent taken? Ki. N2 gas evolve, I will attack there. Fluorobenzene can also be formed. If you remember, benzene will not be converted directly to fluorobenzene. As per NCERT also we have done no reaction. But how to convert? Convert benzene to diazonium chloride. Then fluorobenzene. By which reaction? By treating with firstly fluoroboric acid. And second step, heating. That's it. Diazonium salt to fluorobenzene in 2 steps. Fluoroboric acid and heating, it will give you fluorobenzene. Byproducts, you can go for it. End-to-end Lewis acid. Then benzene can be prepared by diazonium salt. This is very important. Diazonium salts are very important. So many conversions without any detailed mechanism. So direct reactions are useful for those students who have the difficulty in going through the examples where some intermediate formation, some rearrangement, some mechanism based. These are direct reactions. Only learning part should be required. Diazonium salt with mild reducing agents like phosphinic acid, H3PO2, and other one is ethanol. That is given here. Under these conditions, benzene diazonium chloride or arene diazonium chloride converted to benzene formation. What is there? N2 gas evolve. What is there? N2 gas evolve. And what happens to H3PO2? Oxidize to H3PO3, ethanol to CH3CHO. Now it is fine. Is it visible, board? ठीक है. So I was discussing benzene formation. How benzene prepared? Diazonium salt. How many reagents? 2. H3PO2 with water or ethanol. What is formed? Benzene. Remember byproducts. H3PO2 towards H3PO3. Ethanol towards acetaldehyde. This compound can give which test? Tolerance test. Can give Fehling test. Can give iodoform test. Which one? Acetaldehyde. Then phenol formation. How to prepare phenol? Diazonium salt with water. Slight temperature rise required around 283 means 10 degree. Or you can also take weakly acidic medium, aqueous medium. What is generated? OH will attack N2 gas evolve plus HCl. NO2 group can also be introduced. How? First step similar to fluorobenzene preparation, like fluoroboric acid. This fluoroboric acid forms salt. Fluoroborate, which is insoluble in water and stable at room temperature. Then if you heat it, it will give fluorobenzene. If you take sodium nitrite with copper, that solution is mentioned here. Sodium nitrite solution in presence of copper, N2 evolve, nitrobenzene is formed. So these are which reactions? Direct conversion reactions. Diazonium salt to which is prepared? Diazonium is prepared to which compounds? It is converted to chlorobenzene, bromobenzene, benzonitrile, iodobenzene, fluorobenzene to benzene to phenol to nitrobenzene. Observe, so many conversions are given. If you remember these direct reactions, which is learning part purely, nothing involved with the any detailing. So that's why diazonium, if given, you can easily go for it if you remember those conversions. Then which reaction? Coupling reaction. In coupling reaction, what is taken? What's the meaning of coupling reaction? In coupling reaction, we take diazonium chloride, benzene or arene diazonium chloride. It is treated with highly activated ring, like phenol, aniline. Then when they combine, it is which type of reaction? electrophilic substitution reaction. So coupling reaction is an example of ESR. And phenol reacts with this one. It is acting as electrophile. It is activated ring. Use the concept of hydrocarbon chapter, directive influence. Phenol is activating group and ortho para directing. Electrophile majorly attack at para because of steric factor. Ortho will not be given. At para position, N2 attack here and forms which color dye? Orange color dye. Name also important. Para hydroxyazobenzene. Then you can remember it's phenol O, and which dye? O, orange color dye. So there are two colors only in the NCERT given. One is orange dye, one is yellow dye. So phenol O and it is orange. So other will be yellow dye means aniline is left. Other thing, phenol O and here OH minus means weakly basic medium. So this reaction is highly pH sensitive. With phenol, weakly basic medium is taken. ESR reaction takes place. O, orange dye formation. Name para hydroxyazobenzene. This is azo group. Other reaction again important, aniline, activated ring, strongly activated ring, electrophile, NH2 ortho para directing, it will attack again at para position. Major product is there, which is para amino azobenzene, right? And one is O, orange dye, remaining is yellow dye, which is aniline. Which medium? Acidic. How to remember? A for acid, A for aniline. Remember it. One is weakly basic, other is weakly acidic. Okay, so that is the part of the some key points related to which one? Class 12th organic major portion, haloalkanes, haloarenes, alcohol, phenol ethers, carboxylic acid and amines, which are not related to in depth of reaction, direct reactions, direct information. Completed. Okay, so you can go for it. You can go through these points again till exam time. Keep on working. Do not waste time and be positive. Whatever work you have done, whatever grip assignments are there, whatever revision tests are there, that are the most relevant to revise right now. Okay? If it is done in a better way, you can keep on adding the topics, complete the topics which are your strength. Suppose 10 topics you already know, keep on adding one topic. 1 to 10 already there, add one more. Again add and one more, 12 topics. Then keep on adding the topics also. Do in a better way and strategically work that whatever your strength, it remains your strength. And whatever is your weakness, you try to shift it slightly towards your strength side. Till exam time, you have the time available. And then hopefully you will do very best in the exam also. Okay, PDF will be shared in the group. In basic strength, one question is asked, if nothing is given in aliphatic amines. In class also it is told, if aliphatic amines example given, methyl, ethyl, like this, and nothing is mentioned in basic strength, always consider it is aqueous medium. So secondary will be best. Because NCERT solved questions are given, or in text questions given, yes, where nothing is mentioned and answer given secondary more. So from that we can infer that if nothing is given in aliphatic amines, our answer will be as per the aqueous medium. Okay, that's the part of the marathon from my side. Keep on working. Bye. Take care.